Hello viewers, in today's class we are going to discuss a very important limit, right? So here we have a very conceptual problem from the concept of limits. So here the question is limit x tends to 0 plus x times e raised to mod of x plus greatest integer of x minus 2 divided by mod of x plus greatest integer of x is equal to log of e over alpha, right? And we have to find the value of alpha, where alpha is some real number, right? So here this limit is given to be equal to this expression, right? That is log base e over alpha. So we have to find the value of alpha, and in order to find out the value of alpha, what we will do, we'll try to evaluate this limit, right? So let us start. So now let us first denote this limit by the letter L, right? So we can write limit x tends to 0 positive, we have x, then e raised to a mod of x plus greatest integer of x, then minus 2 over mod of x plus greatest integer of x, right? Okay, now here the notation x tends to 0 positive, it implies that we are finding out the right hand limit of this function when x approaches to 0, right? Because here we have x is equal to 0 and x tends to 0 positive implies that the value of x is approaching towards 0 from the right of x is equal to 0, right? Okay, so now let us substitute x is equal to 0 plus h, right? So we are taking x is equal to 0 plus h because all the values of x which lies towards the right of x is equal to 0 are greater than x is equal to 0, right? So if we have to evaluate the left hand limit when x approaches towards 0, then we'll put x is equal to 0 minus h, right? But here since we are calculating the right hand limit, so we'll take x is equal to 0 plus h, where h is a very important quantity in evaluating limits, and h is always greater than 0. It implies h is a positive quantity and h is very small, right? And moreover plus greatest integer of h minus 2 divided by mod of h plus greatest integer of h, right? So now in terms of h, when h tends to 0, the limit is given by this expression. Now see, here we have an important point to discuss, right? See, h tends to 0. Now we cannot directly substitute h is equal to 0 in this expression. So what we will do, we'll take care of these functions, that is the mod function and the greatest integer function, right? So here we cannot directly substitute h is equal to 0, right? So we'll try to assign values to this greatest integer of h and the absolute value of h. So now see, here we have mod of h, right? And since we have just explained that h is a positive quantity, so inside this absolute value sign we have h, and h is a positive quantity, so we can write mod of h is equal to simply h, right? And for greatest integer of h we can write 0. Why? Because see, h lies between 0 and 1. So when here we have 0, here we have 1, so whenever h, the value of h is very small, right, and it is a positive quantity, and when h lies between 0 and 1, then by the definition of greatest integer function, the value of greatest integer of h is equal to 0, right? So now this limit can be written as limit h tends to 0, we have h, and then e raised to mod of h can be written as simply h, and for greatest integer of h we can write 0, then we have minus 2 divided by mod of h can be written as simply h, and for greatest integer of h we'll write 0. So now we have this expression for our limit L. Now we can simplify this expression. So we have a limit h tends to 0, we have h, and inside this bracket we have e raised to h, because h plus 0 is h, then we have minus 2 divided by h, right? And now we see that this h and this h get cancelled, right? So we have a limit h tends to 0 and e raised to h minus 2, and now we can substitute h is equal to 0 over here. So we have e raised to 0 minus 2, and e raised to 0, here e is the exponential number, so e raised to 0 is equal to 1. So we have 1 minus 2, and that is minus 1, right? So the value of this limit L is equal to minus 1, right? So the right hand limit of this function when x approaches to 0 from the right of x is equal to 0 is equal to minus 1. So now viewers, here we have obtained the value of L as minus 1, right? So L is minus 1, and this limit was assumed to be L. So we have also, we are given that L is also equal to log of E over alpha, right? So now log of e over alpha to the base e can be equated to minus 1, right? So we have log of e over alpha is equal to minus 1, right? Now we know that log of e to the base e is equal to 1, right? So we'll make use of this relation over here. So we can write log of e over alpha is equal to minus log of e to the base e, right? So for 1 we have written this expression. So now this can be written as log of e 1 over e, right? So here what we have done, we have written minus log of e as the log of e raised to minus 1, that is the log of e 1 over e, right? So here we have used the property log a raised to b is b log a, right? And obviously the base is e, right? Now let us compare these two expressions, right? This expression and this expression. So here we see that we have e over alpha, and here we have 1 over e, right? So comparing both sides, see we have e over alpha and here we have 1 over e. So now we can write it as alpha is equal to e square, right? Where e is the exponential number. So the value of this alpha is equal to e square, right? So this is how we can solve this type of problems in limits.